Code Review Patterns and Principles with Adrienne Braganza Tacke.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm that serves companies using .NET and Azure, building mission-critical software, rescuing failing projects, and always empowering software delivery teams with a proven approach. Quick announcement, I'm excited to be sharing my latest book, published December of 24. It's now fully available. It's about software leadership. It's called The 5 Pillars, Leadership for Effective Custom Software. It's for anyone who's attempting to make a custom software team highly effective. And if you want your team to deliver world-class results, then the book could be useful to you. Teams are also using the book study guide to guide their retrospective discussions and pull out information. I'm excited about this. So if you, dear listener, would like a complimentary electronic copy of the book, you can just send me an email and I'd be happy to get it to you. And for those of you who are leading groups of software, you might be interested in our monthly software architect forums that I enjoy facilitating. You can sign up for those on clearmeasure.com. My guest today on the show is Adrienne Braganza Tacke, and she is an accomplished author and software engineer with a passion for educating others about software development. Choosing a path distinct from the expected trajectory of nursing, she pursued a degree in management information systems at the University of Nevada in Las Vegas. And over the course of nearly 8 years in the field, she's contributed her expertise across multiple industries, including healthcare and higher education. Currently, she serves as a software development engineer at DebtTrader, where she embraces the challenge of modernizing fintech workflows traditionally dependent on spreadsheets. But beyond her professional work, Adrienne is an international speaker and instructor and a dedicated advocate for STEM education. Her first book, Coding for Kids in Python, has consistently ranked among the top-selling children's books on Amazon for programming. And beyond having that book, she frequently visits schools to inspire students with insights into software engineering and the transformative power of coding. And when she's not engaging with the aspiring developers, she speaks at tech conferences throughout the US and Europe. And you can follow her on Twitter and Instagram to stay updated on her latest endeavors. And we'll include links to both of those in the show notes, as well as anything else we talk about. But Adrienne, welcome to the podcast. How are you today?
I'm great. Thank you for having me, Jeffrey.
My pleasure. My pleasure. You've been doing a lot of speaking on various topics, but one that caught my eye, it's really, really interesting, is been your work and guidance on code reviews and code review patterns. And that's important for any teams. I want to kind of ask you about that. But before we kind of dive into that for listeners who haven't heard you speak or aren't familiar, if you could kind of back up, what has your journey been, and what are maybe the formative moments that have led you to working in this field, doing the work that you're doing today?
I like to think about my career as a series of happy accidents. A lot of the things that I do now are not things that I knew that I wanted to do when I was a young child. I'm not one of those that said, I'm definitely going to get into programming. That's not something I wanted to do. I actually wanted to be a pastry chef when I was
Nice.
younger. And that was always my dream job, still kind of is. Maybe it's what I'll do when I retire. But I got into STEM in general when I first got my student job in college at UNLV. I was a student help desk technician, and not because I was interested in resetting people's passwords or troubleshooting why their computer was not working, but it's because it was the highest paying job as a student. So that's really what
Smart.
first led me there. Yeah. And it was through that experience that I started to slowly become exposed to the problem solving aspects, the breaking things down into smaller concrete steps, and then teaching others how to resolve their own problems or to go through things. So that was a very foundational part for me. Same thing with software development in general. There was an internship that came about. And again, it was to help with school, not necessarily because I was interested in development itself. But as I got the internship and I started to work with the team at UNLV, I started to actually like development. I first worked with some Google APIs. We had to do some administrative applications for the email system at that time. And I started to actually, get into it and like it. What I currently do now is I'm actually a developer advocate at VM. So I need to update the little bio I gave up earlier, but I'm a developer advocate at VM where we work with robotics, and we are trying to be a platform for robotics and make it easier for anybody to build whatever they need with hardware or components. And it's the same thing. I like to teach developers how to do things. And through my own experiences at talking at conferences and building, tutorials, I've really learned to like being able to break things down into simpler concepts and to make them more fun so that you can remember them a little bit longer and have those principles last a little bit longer. So skipped a lot there, but let's just say a lot of the accidents led me to where I am today.
It seems like the calling of teaching has been tugging at you along the way.
It seems like it. When I really first started teaching was probably around 2017, 2018, around that time. And this is when Instagram started to become a thing in terms of tech influencers, you could call it.
Mm-hmm.
And I saw a lot of folks sharing their stories and sharing what they're learning. And at that time, this was when I was still fully a software engineer at DebtTrader. We were migrating our on-prem application to Azure. And so there was a lot I was learning at that time. And cloud development was, the hot thing at the time. Everyone was like, get your certificates, learn, pick one of the clouds and, you'll be guaranteed a job. But at that time, there was a lot of interest around what is cloud development? What are, resource groups? What's a subscription? How do you develop on the cloud? And so I started sharing that through Instagram, and that were the humble beginnings, let's just say, of where I started to say, hey, I actually kind of like breaking things down and sharing them in my own voice. And that seemed to resonate with a lot of people.
Yeah. So important. So you've been doing a lot of teaching and speaking and sharing on code reviews, and generally for, I don't know how many decades, everybody has needed to kind of make sure that new code was good in whatever form you classified good, standards, it worked. Just before we push it along, okay, we need to have some type of team level check. And the concept of a code review, is long standing. But yeah, there's no industry standard. And what does that mean? What should be included? What do we look for? How do you think about that? What opinions have you formulated as you've kind of examined that part of the process?
That's a good question. I think after pouring 2 years into researching this and writing the whole book, Looks Good to Me, which is all about code reviews, it comes down to there is no one size fits all about code review process that will apply to every team. It's rather you have to build it from the ground up and it base those decisions on the way that your team works. So if I had to do TLDR, it's you definitely still need code reviews, and what that process looks like will depend on your team. So those are definitely two opinions that I still stand by. What the code review looks like will be different for every team. If you are a small, tight-knit group of 5 people and you're all experienced and you know how each other works, you know the history, the nuance, the quirks, the decisions behind why your code base has evolved the way that it has or why you did something a particular way, then yeah, your code review process might be a bit more lenient. You are not as stringent, or you are probably have tests or automation in place to do some of the checks that you've experienced over the years. But if you're a larger team, or you're a mixed team of different experience levels, and there are some folks who may not know parts of the code base, any of these reasons are good reasons to say, let's take an extra look at it, and also be a bit more stringent, because you may not know what the standards are. You may not know what your project guidelines are. And that's why a code review is so important, to not only learn what those are and try to acclimate to the team's way of writing that code, but to also improve overall the code base itself, because you're now trying, hopefully, communicating with the rest of your team and coming together and having that collaborative ownership over the code that you're all working on.
Yeah. In your kind of research and experience, is there some big common mistakes that seemingly a lot of people do?
Absolutely. I did a whole talk on it where I said, here are all the mistakes that we're doing. And you have to look at it from the point of view of a reviewer and an author, because with those two roles, there are plenty of things that we do wrong. But for example, as a reviewer, probably the biggest thing that we do wrong is ineffective communication. We don't write effective code review comments. And this is the cause of why code reviews take so long. This is the cause of debates, because people start talking, they can't clearly describe what they're asking for, or they pinpoint on something that isn't important. It all comes down to good communication. And I think as reviewers, and partially authors, but in the role of a reviewer where you're expected to give feedback, I think that's one of the things that we have a lot of work to do on. As authors, the one thing that I see time and time again, I'm guilty myself before and sometimes now, but one thing we do wrong is to just make our PRs or our pull requests or code changes just too dang large. We send, 50 files or a few thousand lines of code to someone and expect them to give it a proper review or to catch things that we may not have seen. And so that's probably the biggest thing that we do wrong as an author, is we make our PRs unmanageable, and we make it nearly impossible for the reviewer to give it a proper review.
Yeah, that's a common joke, or what they call it, a meme or whatnot. And you mentioned it in one of your talks, I think, is the 5-line code review with 25 comments, and then the 1,000-line code review that says, looks good to me.
Mm-hmm.
Hence the title of your book.
Exactly. It's kind of depending where you are on that process, as an author, you're like, I just want it, just rubber stamp it. And that's kind of the wrong mindset to have. But as a reviewer, if you're looking at this, again, if it's something unmanageable or unwieldy, it's very tempting to just say, looks good to me, because you don't, for whatever reason, you don't go through. There are exceptions. I'm not saying all developers are like that. There are some very rare few awesome people out there who they go through and they trudge through it, but that's not what we want to promote. We should try to make it better for both sides.
Yeah. Beyond the style conversation, like naming or anything that you could say is purely subjective, beyond those kinds of comments, how do we get to code reviews where we can really verify that the changes in this branch where we have a pull request actually conform to the architecture that we've decided that we were going to stick to as a team, versus, no, the changes in here actually change something structural that maybe weren't intended. And we're just looking at lines of code. But how do you think about that?
That's a great question. That's really difficult for teams to decide, especially when you're looking at code in isolation. But I think one of the fundamental things you need to decide first as a team is, what is the most important thing you want for your code base? Is it like everyone's going to say, we want a little bit of everything, right? We want the structure, we want the legibility, we want the maintainability, but that's going to look different across all teams. If you can be as explicit about what those things mean, like maybe you are totally for legible, clear variable names. That's the most important thing for this project and for your team. Then that might be a priority, say, over longer functions or shorter functions. It's going to depend on the team and what's most important to them. Now, if you have guidelines around your project, that's obviously always a great place to start. Just like with styling guides, you eliminate a lot of that, debate, and you automate away that low-hanging fruit of potential debate and disagreements. Because as a team, you've said, here's our style linting rules. We've all agreed to it. Automate it away. Mm-hmm. And alongside of that, if there's anything you can automate beforehand, I always say if you can fix things during development, whether that's running tests, whether that's going through static analysis that has been conformed to the rules that are important for your team, and that's using, linting and formatting rules. If you do as much of that as possible before the code review, that's also very helpful because, again, you at least now have a baseline to work off with. And once code reaches the code review, your team can at least say, okay, we've gone through these initial checks. We know that this code has gone through the low-hanging fruit of things that I don't need to look for. And another thing that might be helpful is also deciding what are those guidelines or what are your blocking versus non-blocking issues. So for example, if you're looking at a piece of code and it tends to change from what other pieces of logic might look like in the rest of your code base, is that something to your team that is worth blocking? For some teams, they might have examples that say, no, we needed to do it this way because some library, doesn't support it and we need to work on this for now. Other times there's just, yes, we definitely want to stay aligned and we don't want to start to drift in how our code base is structured. That's way more important to us. We need to keep it in this way. So it's, there's no direct, clear answer, but the closer you can get to explicit guidelines of what, maintainability means for your team, mm-hmm. the likelier it is for you to go through the code review and say, oh, okay, it is, along the lines of our team guidelines, or, oh, this looks a little bit off, or, oh, you might even just start a question and ask, and it should be okay to start that conversation and say, this might stray from what we've usually done. Is there a reason why? And so I think those are good baselines to have with your team rather than just having like strict rules. It looks this way, no, or it looks this way, yes.
Yeah. You mentioned linting as something that doesn't really need to be a human code reviewer. We can now have tools that just automate. Oh, it's an error. Okay, go ahead and take care of that instead of a person having to find all those little things. And I remember before we had good Roslyn analyzers for C#, there's so many more warnings that we can elevate as errors and have a much higher quality branch before we can get to the code review process. In your experience, what are the tools or the types of problems where if you're just starting on a new project today, you really should automate, certain classes and not just expect those to be caught in a human code review?
Absolutely. The first thing I do when I join a team is ask, do we have a style guide and do we have any type of rules that we are using? It could even be as bare minimum as an automated script that you might have to manually run, but that's always great because at least there are some agreed upon rules that you can automate. So that's what I always ask for first. One story that comes to mind is when I worked with our team, when we would get to our code reviews, we would have this problem. We would spend so much time talking about spacing and talking about specifically taking out console logs in our code. And we would have like 10, 15 comments just saying, you forgot this, or take your debug code out. Mm-hmm. And it was such a time waster for both sides. One, because the author should know to just take those out, clean up your branch a little bit and prepare it. But then also for the reviewer, because now you're wasting time. And I truly consider it wasting time on things that should just never make it in the code review at all. So when you start to see these like common issues that occur that can be automated away, then I highly, highly encourage using a linter and making it a rule. So we use ESLint, and specifically there is a rule that says, that flags it, and we flagged it to the severity of an error rather than just a warning to say, if you have any debug code in here, make sure you take it out. If you have any very complicated checks that could be simplified, change those to be more simplified rather than the more complicated checks. If you have unused variables, take those out. When we were switching over to JavaScript during that time where we introduced let and const rather than just making it var everywhere, we wanted to prefer the more strict forms of declaration. So there were rules for that. There are rules for almost everything.
Yeah.
So you can start out with some of the low hanging fruit, like the debug errors, like those unused variables, and start with those basis. And as you start to go through your code review process and you find yourself, pointing things out that can be automated away, try to add those to your lists and try to add those to your automation that you can do beforehand. It got to the point where we had, I think, over 120 different rules, but it's as nice as automated testing because you can say, let me do this one last check before I open my pull request. And if there's anything else that's left, it's my responsibility as an author to fix these before I send it up. So it's another thing that I can use to make sure that it's ready for the reviewer.
And you said DSLint, and you said JavaScript, just for the listeners, that sounds like a JavaScript specific linting tool. What I've seen, and I'm certainly not familiar with all of them, but I've seen every programming language under the sun has various tools that fall under the umbrella of static analysis that can that have sets of rules you can configure, and also have default rule sets where just basic mistakes, it can save so much time. So whether it's the C# or JavaScript or TypeScript or C++ or HTML or CSS, it's like literally every type of code file has tools out there that can inspect it and can find various issues just automatically. So
absolutely, it's so important. I think it might be it's likely some of it is outdated, but I've included an appendix in my book that lists all the static analyzers that are available for almost every language out there. So just find your language. There is something out there that you can definitely use. It will save a lot of time.
Yes. I'm reminded of the book's from 2006. It was 19 years old, but it was the first book. It was titled Continuous Integration. And one of the parts of the integration build and the private build was just running quality tools. Well, in 2006, they were a little bit less mature, but now 19 years later, you got the static analyzers for everything. And the research by Capers-Jones has listed static analysis as one of the top 3 most effective techniques for increasing quality of code, is putting that static analysis steps in the build. And so this is how I think about it. I want to see if you agree. If we run our build script before the pull request and our build script includes those static analysis tools, then just automatically we'll never submit a pull request that has build errors. What else do you think needs to go in that process?
I always, one of the chapters I wrote is, if you can automate it, do it. And if you can do it before the code review process, do it. And I also make mention that, I talk about code reviews a lot, but it's important to understand that within the context of a larger CI/CD system and a whole robust system of checks and balances. So the code review is one important part of it, but I'm absolutely not saying like, if you only do a code review, you're golden. Not at all.
Yeah.
I think adding it to something like an automated CI/CD pipeline is absolutely necessary. And doing these checks beforehand, as well as in those pipelines, it's only giving you extra assurances that things are caught that you might not catch. And it also gives you extra assurances that, when it has gone through and pretty much done a dry run, you can be extra sure. So it actually in my opinion, saves you time as a reviewer, because if you do a lot of these checks, for example, GitHub, you may have seen this before, when you have it deployed, it sometimes does a pre-merge and it checks for any conflicts and it tells you right away. And that's a really nice check to be able to say, oh, this isn't even ready because there might be a conflict or something else that you might need to fix. So yeah, I agree with you in that more of these checks in process to an extent, because I've been on the other extreme where it's a bit too cumbersome, but the more checks that you can do to consistently give you the assurances that your code is ready to be merged, the better.
That's a good point. It makes me think of person time as the most valuable, the most expensive, the most important asset of the team. And all of this automation time is much cheaper, much more plentiful. And whenever we create a pull request and ask for that code review, and let's say that it was approved, and then it breaks the build, that's a failure right there. It's like, no, we shouldn't be asking for that review unless we've already verified, even back merging from the master branch to our feature branch and running the build. We've already verified this is going to result in a green build. Now I'm asking for that personal look at it.
Exactly. I actually prefer that method as well. There are a lot of teams who kind of use that last check as the final check, and it's much better when you do it the way that you've just described, which is you've basically gone through every single check that can be automated away, and now you can focus. So if you were to compare that to a very manual code review where you're looking for those formatting issues, you find simple errors or there are merged conflicts, now you are using that expensive human time to point out these things rather than, say, looking at something and there's an egregious error that might not be found. I think another thing people forget is that you can automate as much of it as possible, and you definitely should, but there are still errors that will just not be caught by static analysis. Yeah, and right. A perfect example I wrote about is there's perfectly good code, no errors, everything is great, matches guidelines, all of that, and does not flag anything. But when you look at it as someone on that team, you are able to say, oh, that's calling the wrong cache, or, oh, this is actually using a library that's from our legacy code rather than the correct call. So that's the stuff that you want humans to spend their time on. Those are the types of things that you still need a code review for, in my opinion, even in the age of AI. And those are the things that will make it more effective because you've let the machines take care of the mundane things that they're better at and looking for and enforcing those rules. And then, you use your time for the higher level situations that you want to look for.
Yeah. Now, since you invoked the 2-letter acronym AI that you know of, are there any, newfangled Gen AI tools that are static analyzers that can be added to, be a pre-filter to catch things?
Yes. So there are a few tools I've been watching them. When I wrote the book, obviously they're already outdated, but I've been keeping up with their progress. The one that I will say looks really interesting are Code Rabbit AI. So what they do is they take a look at your pull requests, and they initially, when I wrote about it, they wanted to solve the problem of getting feedback faster. So that's another issue, right? Where you send up your PR, you're waiting for the reviewer, you're like, hey, can you take a look at it? And it just, for whatever reason, it takes forever. With Code Rabbit AI, what they proposed is you can actually just start chatting in the threads about your code. You can even have it suggest initial suggestions of what to fix. Based on what it's learned about your code and based on what previous code reviews look like and what your colleagues may have suggested before. So that has been getting a lot better. And I absolutely agree with that as like a first pass, a first initial review to say, hey, here are the initial things I found. And then you can come in as a human to, again, verify, look at it. It's like a nice summarized report for you to look at rather than taking that extra time to go through. So That's one tool that I think has a lot of promise. Another one is called, I think they've changed their name since then, but what they had was an agent where you can run some commands and it would help describe your code. So for example, if you did a /describe, it would do its best to explain what is happening there. You could also do a /suggest, and same thing. What could it optimize? Are there better ways to implement this? And those I think are great for, again, the conversation between a reviewer and an author, and to also get onto the same page a lot faster because you can already have that conversation with the AI, but also find something that's a bit more objective. So those two are definitely there. Some that are AI adjacent, I will say, are tools that kind of enforce, say, your pull requests themselves. So for example, if you have a format for, say, your PR titles, I highly recommend just using AI to enforce that, to say, make sure your titles are descriptive. Or if you're using conventional formats like conventional commits or conventional comments, make sure they follow that structure so that everybody is using the same form. In terms of that type of enforcement, I think AI is great. And then the last one I remember that's off the top of my head is using AI to kind of just in general summarize what is going on, and to also summarize what is going on in the code. So this is from the author perspective. We always ask you to describe what's going on. This is a great place that I agree with to generate a summary of what's happening in your code, and not just leave it at that. Obviously, check it, review it, make sure it's correct, but it's a great time saver, and you get the benefit of having a detailed PR rather than just an empty one where you leave it to the reviewer to guess what's going on.
Nice. That your favorite tool for auto generating the PR titles. What was that? Was that just the GitHub Copilot built in, or was that?
Yes, there's GitHub Copilot built in. Unfortunately, I think it's only available on Enterprise, but they do have a GitHub Copilot either tool or AI that is specific to pull requests. So a lot of the things I talk about, they offer it there. And then even if you don't use that, I believe there are GitHub actions that do the same thing. So not quite AI, but they get the same, they have the same intent and purpose.
We'll include the link in the show notes. And then just closing topic for us, this is more just interpersonal and maybe philosophy. When I've got feedback for a code review, in your opinion, is it generally better to treat it like a message board with like comments back and forth, or say, you know what, I reviewed it, and if it's not just a quick thing, okay, get on. Let's have a face-to-face conversation about this. What's your opinion?
It depends, but yes, for the most part, I say if you are even like 2 or 3 comments into a thread going back and forth about something, absolutely get off of the screen and get on a video call or tap them on the shoulder to have a synchronous conversation, because a lot is lost, as we all know, through the screen. And if you can figure it out right there in that small conversation, the better. A lot of the reasons why code reviews take too long is because of that. Sometimes there's a delay in getting back. Sometimes there's a delay in formulating your thoughts correctly and clearly in a written format. Sometimes there might be language barriers, time zone barriers. But if there is a place for you to be able to talk synchronously, it tends to get you onto the same page faster. I'm not saying you're going to agree, but it will definitely get you through to hopefully understand each other a little bit better, and then resolve whatever it is that you might be debating or discussing. And one part about that too, so a lot of people think about this, which is great, but one thing I always advise is if you do have an offline conversation, take like 2 minutes to go back to the PR and add another comment with the conclusion or result of that conversation. Because you may have talked about it, but then that's another place where knowledge might be siloed, or a decision was made and the rest of the team might not know because you only talked about it offline. So if you just take a quick summary of what was decided, add it back to that PR, now anybody that goes back and references that can understand where that code went. Did we stop the PR because it's not actually needed? Or are we going to go back because more rework needs to be done? Whatever the case is, you now, give the rest of your team some insight into that conversation you had offline.
Yeah, good point. This research is it's over 20 years old. It's probably older than that. I remember kind of getting taught it early in my career when email was first becoming popular. Probably been out for 10 years by then, but it was the guidance of putting things in text versus voice communication. And at that time it was just telephone versus in person, where you're also seeing the facial expressions and the exponential amount of lost information when you go from being able to see the face and have the conversation to only the voice, on the telephone only, and then no voice, but just reading comments. And now there's so many more avenues where all we see is text, no facial expressions, no voice intonation. We have to infer, did they write that with some emotion, or did they write it in a pure story fashion? I don't know. I'm going to guess, and then I'm going to assume, and then I'm going to assume wrong. And so now pull request is just yet another way where I just have the text, and I'm waiting for that button on these tools that just says auto polite, where whatever I wrote, it just fluffs it up a little bit just to make it easier for the person to read it in a generally polite manner.
It's really funny you say that, because I've started to see a trend. I've spoken to a couple of developers at conferences when we talk about code reviews, specifically about this. And a lot of folks are now writing out their comment into ChatGPT or Claude or whatever. And they say, can you write this from an objective perspective so that it is clear and will also not offend the reader? And that they go through this check to make sure that it is written in such a way. And for some teams, they say it's actually been helping, especially if there's been some history of either ego or communication issues. But like I said, it's funny that you brought that up, because people are now starting to use these tools. That's one example for good, and to really, take into account that it does matter how you say things. I know myself, I try to infuse that emotion that is lost by being very emoji forward to, try to encapsulate how I'm feeling about what I'm saying, and to make sure it's not coming across as antagonistic or you better do this, but more like a, hey, what do you think about this?
Right,
so if you only see the text, it really depends how you perceive it and how you read it.
Right. Yep. My high school daughter was making fun of me for actually using texting back and forth, for actually using emoticons instead of emojis. She's like, what is that? Just give me the smiley picture.
Those are the OG. Yeah.
Right. It's like, no. My generation, we invented emoticons. Actually, we didn't. The typewriter generation did, but
you don't need a whole different keyboard either.
That's right.
Those are the good old days.
Well, Adrienne, thank you so much for coming on the podcast and sharing with us your philosophy on code reviews, and your book Looks Good to Me. We'll include those links in the show notes. But this was a fascinating conversation. I really enjoyed it. Thanks so much.
Yeah, thank you for having me. I always love talking about it. And yeah, if you have any other questions, feel free to hit me up on any of the social links. I love talking about code reviews.
Yes, ma'am.
Thank you for having me.
Oh, my pleasure. My pleasure. And until next time, dear listener, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.